Hello and welcome into the second video for lesson 2. This is going to be the problems, the examples of applying our exponents, our radicals, and rationalization. So let me share my document camera for you guys. All right, so first, I'm going to look at some problems applying the properties of our exponents. So the first one, I want to simplify 2 to the third times 2 to the 8th. So if you remember, our first property says that what? If we have the same base, which in this case we do, both have the base of 2, and we're multiplying, we do what? We add the exponents. So this becomes 2 to the 3 plus 8, or 2 to the 11th power. So that's when we're multiplying. What if I have 2 to the third over 2 to the 8th? Well, according to my exponent rules, my properties, when I'm dividing, I subtract, right? So 2 to the third minus 8. So 3 minus 8 is negative 5. But we do not want negative exponents. So how do I get 2 to the negative 5th power to have a positive exponent? I take it to the denominator. So 1 over 2 to the 5th power. Let me take a little break here, do a little bit more teaching. So you guys get the bonus here for checking out this video. So we saw there was several steps, right? We applied the property. We ended up with a negative exponent. We got to get rid of the negative exponent. When we are simplifying exponent problems that have a fraction, we can do the following shortcut. And again, he's like, okay, more shortcuts. Yes, I will try to give you shortcuts when they always work. So if things don't always work according to a certain method, then I won't give it to you. I don't want you to have to worry about, well, does it work this time or not? If I'm giving you a shortcut, it's always going to work. So when we're simplifying these, the first thing we want to do is identify where is the largest exponent. And based on that, that's where the number or variable ends up. And then to figure out what's the exponent, we subtract the large exponent minus the small exponent. So for this problem here, 2 to the third over 2 to the 8th, well, they have the same base of 2. The bigger exponent's in the bottom so that I know the base 2 is going to end up in the denominator. And then so I need 1 in the top for my placeholder there. And to figure out what the exponent is going to be, it's the large one, 8, minus the small one, 3. This will always end up positive. If you get a negative number here, then you're not subtracting large minus small. And then you have an error in what you're doing. When you do large minus small, this always better end up positive. It's 5. So that means the exponent then becomes the 5th power. So 1 over 2 to the 5th, which is the same answer we got up here. It was just a lot less steps and a lot less calculations. And right now it's like, well, is he really saving me much time? Maybe not on this problem, but some future problems we're going to look at here on this video, it will absolutely save us a lot of time and a lot of steps, which means less dumb mistakes, hopefully. So that's that shortcut there. The third problem with my exponent properties here is 2 to the third power all to the 8th power. So this is what? This is a base to a power to a power. So we multiply the exponents 3 times 8, meaning this is 2 to the 24th power. So that's applying our exponent properties. How about our radical properties? So let's say we want to simplify the square root of 2 times the square root of 18. Well, square root of 2 is not a nice number. Square root of 18 is not a nice number. But if we apply our first property, this is the same as if I combine them. 2 times 18. And 2 times 18 is 36. And square root of 36 is what? 6 times 6. So that's what I pull out. So my answer then would be 6. Division. If I have square root of 18 over square root of 2. Well, again, square root of 18, not very nice. Square root of 2, not very nice. But because of my rules, properties, I can combine these. 18 over 2. And 18 over 2 is 9. So square root of 9 is 3. So the answer to this one would be 3. And again, like I mentioned in the lesson 1 problem video, you guys, once I give you the problem, you can hit pause and try to work it, and hopefully you end up with the right answer. What if I have addition or subtraction? So addition or subtraction, we have that big warning, right? The root and the radicand must be the same. So what if I have square root of 2 plus square root of 18? Well, George, you can't do it. Yes, they're both square root, but they have different radicands, so you can't add them. That's true, the way that this is written, but can I rewrite these in any way so that they do have the same root and the same radicand? And so I'm going to simplify the square root of 18. So I can really write this as what? Square root of 9 times 2. And now with my radical properties, this is like square root of 9 times square root of 2. And square root of 9 is 3. So square root of 18, I could really rewrite it as 3 root 2. And then I have this one still out here in front, square root of 2. So square root of 2 plus square root of 18 is the same thing as square root of 2 plus 3 square root of 2. If you want to think back to like your basic algebra, x plus 3x. And that's all we're doing here. Once I have the same roots and once I have the same radicand, I'm just adding or subtracting the coefficients. So the invisible 1 here, 1 root 2 plus 3 root 2 is 4 times the square root of 2. So that's how we would add or subtract radicals, assuming they don't have the same root or radicand to begin. So again, the root and radicand have to be the same. All right, couple more exponent problems. What if I have negative 2 to the 4th power? So go ahead and try that one real quick. So this means what? This means negative 2 times negative 2 times negative 2 times negative 2. So 4 negatives become a positive. 2 times 2 times 2 times 2 is 16. So the answer to this is positive 16. What if I have negative 2 to the 4th power? It's like, well, George, we just did this. No, we did not, because these are different, right? This one up here has parentheses, meaning this 4 is attached to everything here. But in this case, because there's no parentheses, this minus sign is out in front. So it's really minus 2 to the 4th power. And 2 to the 4th power is 16. So this one actually ends up negative 16 as an answer. Hopefully that makes sense to everybody, the difference in them. Is the negative included because it's inside the parentheses, or is the negative just out in front and we still have to account for it? All right, let's try a couple harder ones here. We're going to simplify. The first one is 3x to the fourth, y to the minus 2 over x to the minus fourth, y to the minus 9. So we're basically going to look at this as three different problems. So we're going to look at it as the number part. We're going to look at it as my x variables and my y variables. So again, there's this invisible 1 here. So this is what? 3 over 1 is 3. So that stays up in the top. And now for the variable parts, we can use that shortcut, right? So if I use the shortcut here, what's the first thing I ask? Well, where is the bigger exponent? Well, on the x terms, the bigger exponent is in the top, meaning the x is going to end up in the top. And how do I figure out what exponent goes on here? It's the big number 4 minus the small one, negative 4. 4 minus negative 4 is like 4 plus 4, which is 8. So this x gets an 8 on it. And now same thing for the y's. Where's the bigger number? Well, I have a negative 2 and a negative 9. Which is bigger? Or if you want to think of which is better, would you rather owe somebody $2 or rather owe somebody $9? Obviously, the negative 2 is bigger than negative 9, meaning the y is also going to end up in the top. And to figure out what's left, I have the big number, negative 2, minus the small number, negative 9. Negative 2 minus negative 9 is like negative 2 plus 9, which is 7. So I get a 7 on the y variable, and then this is my answer, right? 3x to the 8th times y to the 7th. How about 2a to the minus 1b over a to the third b to the minus 2 all to the negative 4th power. So this one has a whole bunch going on, right? There's several ways you could solve this. There's not like one way, like, oh, this is how you have to do it every time. You could combine everything inside. You could bring in the negative 4 using our exponent rules. But my suggestion to you, and it's going to save you a lot of headache later, is get rid of this negative 4 first. And so we do that how? We flip everything that's inside. That was our rule number 4, I think it was. Let me pull up the paper here. 6, sorry, rule number 6. Rule number 6, when I have a negative exponent on the outside, flip what's inside and the exponent becomes positive. So that's what I'm going to do here. Flip what's inside. So a to the third, b to the minus 2, 2, a to the minus 1, b. You notice I didn't change any pluses or minuses inside. All I did was make the numerator the denominator and the denominator the numerator. And then make this exponent positive, so 4. Now, go ahead, or one of the options is to bring this 4 into everything. So we have what? A to the third power to the fourth power, I multiply exponents, so that's a to the 12th. Negative 2 times 4 is negative 8. Be careful here because this is 2 to the fourth power. Not 2 times 4, but 2 to the fourth power. Negative 1 times 4 is negative 4. And there's like an invisible 1 here, so 1 times 4 is 4. So once again, I basically have 3 pieces. If I deal with the number part first, I have a 1 in the numerator, 2 to the fourth in the bottom. So that means 2 to the fourth, which is 16, stays in the bottom. And now the a, where's the bigger exponent? In the top. So a is going to be in the top. 12 minus -4. Remember, it's big minus small. 12 minus -4 is 12 plus 4. So that's 16. And then b, the bigger exponent is in the bottom. 4 minus -8 is like 4 plus 8, which is 12. So this would be your answer for this one. A to the 16th over 16, b to the 12th power. Then last but not least, our rationalized problems. First one, rationalize 1 over square root of 10. So you could do it mathematically. You can multiply top and bottom by root 10, or you can do the shortcut, which is multiply the top by the radical and get rid of the root symbol in the bottom. So root 10 over 10. What if I have 3 over square root of 6? Well, shortcut, multiply the top by the radical, get rid of the root symbol. But I'm not done. Simplify this guy. I can cancel 3 here is 1, 3 here is 2. So root 6 over 2 would be the answer for this one, fully simplified. Last but not least, what if I have square root of x over 7? Well, the first thing I need to do is break this apart with my radical rules. So this is like square root of x over square root of 7. Now multiply the top and bottom, or sorry, multiply the top by the root, if we're doing shortcut, and get rid of the root symbol on the bottom. But again, I want to simplify this, so using your radical rules, they have the same root, so multiply what's underneath. So I get square root of 7x over 7. And that is it. Different types of rationalizing that we have. So just basic one, sort of basic, but we have to simplify. And then this one, we have to apply our radical rules a couple times, break it apart, do the shortcut, apply the rule to multiply everything together. You get root 7 over 7, root 7x over 7. And that's it for our example problems. Again, these are very similar to what you'll have on the web assigned homework set. So give those a try and see how you do. And we will see you guys for lesson 3.